Test, test, test. ¿Estamos? Hola. Bueno, sentados, por favor. Vale. Pues, buenos días a todos.
Well, good morning, everyone. So let's move on now. We'll speak in Spanish. So those of you who will need the English translation or interpretation, please pick up some headphones. So welcome. Today we're lucky enough to have had the inspirational talk by the Hassani brothers, and now we changed to something completely different. But it's also revolutionary. So we have invited two Spanish scientists, Nieves Cubo and Maria Postigo. So I'm going to introduce them first, or we have a video to introduce them.
Nieves Cubo es investigadora e ingeniera industrial especializada en ciencia e ingeniería de materiales. Actualmente trabaja en la investigación sobre el uso de técnicas de impresión 3D para la fabricación de tejidos humanos. Open Bioprinting. Un gran avance en el desarrollo de la medicina regenerativa con cientos de posibilidades. María Postigo es ingeniera biomédica especializada en tecnologías y estrategias para el desarrollo. Es Product Manager de SpotLab, una startup que desarrolla tecnología para democratizar el acceso a la salud. Forma parte de Malaria Spot, el videojuego que usa inteligencia artificial y la participación ciudadana para el diagnóstico colaborativo de malaria, un proyecto reconocido por el MIT Technology Review. Actualmente se centran en el desarrollo de dispositivos médicos low cost a través de nuevas tecnologías.
Bienvenidas.
So welcome to Malaga, and thank you for accepting our invitation. So to start with, I'd like to ask you, how was your, for example, how was your day on Friday, your normal day of a Spanish scientist? So, for example, last Friday, we had maybe 2 milestones. We're now developing medical diagnosis technologies because we want to reduce the cost to 10% of the current cost of many devices. We are now creating a portable microscope, to detect malaria and, for example, also cancer. And Friday, precisely, we took it to the 12 de Octubre hospital in Madrid, and we tested a new service. Our industrial engineer, specialist in 3D printing, made up a holder for a new optic device, and we went to the 12 de Octubre hospital to test it on Friday. So we took a picture of malaria cells, epithelial cells and tumor cells, and the malaria parasite for the first time, which is really, really, really tiny. There can be 12 million malaria parasites in one grain of rice. For example, you can see one here. This is the first prototype. And so we have now a new holder devised by the industrial engineer, and we tested, and it worked. right first time. And so he made it from scratch, and we still have to test it. So it is the first time we've been able to see these parasites. And so we're now submitting this project to a call for subsidies, and we managed to submit all the documentation in time. So what about you? How was your last week? So stressful? Yeah, more or less the same. Friday, we were drafting a proposal for a new project because we need funding, European funding, because we have collaborators located abroad. And it is very stressful indeed, because we have the deadline for submitting the documents on September the 27th, and we have to coordinate our actions with 7 or 8 countries. It has to be a coherent set of documentation, and we need to show that the project is critical. Because even if you see that it is useful and that people show interest in it, then money it's very difficult to obtain, because it's a very long-term action. We want to replace metal prostheses with human tissue prostheses. So we take samples of tissues from a human body, and then we develop the prostheses starting from that tissue. So it's a 10-year project, and it is very, very difficult to get public funding for a long-term project. We only want public funding. So on Friday, did you manage to submit all the documentation? No, the deadline is on September 27th, so we still have some time, but we really do have some partial deliveries. I am the European coordinator, and almost all of them submitted all the documentation on time. So there are 7, 8 countries and 2, 3 leading researchers for each group, for each country, and then a group of interns and PhD students. So for each country, it should be like 20, 30 euros, and several disciplines, tissues, technologies, etc. So today we're talking about Ehealth or Ehealth. So have you heard about this in the audience? Is there any of you who works in the Ehealth sector? 1 person, 2 people? So I think maybe it's the time for you to explain it. So what is the Ehealth? What is Ehealth? What does it mean? And what about 3D printing? How are you involved in 3D printing? And how it has changed your life? Well, for me, Ehealth is like the advent of all these technologies to the medical area. For example, tissue engineering, medical imaging, communication with patients. We're working for the doctor and the patient to be more closely linked, more communicated, more in touch, instead of a person waiting for a document or a record to be sent to the clinics, and then him picking it up from here. It can be sent directly to their homes, because it is devised for facilitating people's lives. And then there are technologies for digital production, digital manufacturing, and that can be shared. Printers allow us to share physical things, hardware. You can devise or design something and send it to elsewhere in the world. So it is a very sharing platform. I can put up a design and I can share it through the internet, and while I'm sleeping, another person might receive it at the other side of the world. So anyone can collaborate to it, can contribute to it. This is what 3D printing means for us. It is also low cost, it is scalable, you can send it anywhere. You have to be careful, of course, if you're working with human tissues within hospitals. You need, of course, a sterile, pathogen-free environment, but you can also make custom-made tools. You can devise new things for the operating theater, for the operating room. But it has enabled us to develop our own prototypes. Anyone can develop a prototype in a very simple, low-cost way. So I have to insist a little bit more. Yesterday, I saw an image of Wendy. Who's Wendy? And why were you saying goodbye to Wendy? Well, when I started working on 3D printing, I was still studying at uni. I was studying domotics or home automation. And when I was at the third year at university, in my university, the Carlos III, there was a group of people who wanted to do something after class. So we started to create our own prototype, and that's how we started to devise, to manufacture these 3D printers. Am I making this noise? Yes, I am. It's me. So we started to set up our new printers, and Wendy was my first 3D printer. It's the one you can see here in the picture, and it is the one who changed my life. Yeah, because last week, Wendy retired. You sent them away. You sent her away. This was, my first printer, the one who enabled me, the one that enabled me to set up a new printer to work with human tissues. But this was really the mother of all printers, but it was a little bit obsolete. But it was the beginning. So very recently, a friend of mine who's also studying from in another place told me where I wish I had a 3D printer, and I said, okay, I love Wendy, but we're not using it anymore, so maybe you can use it. I sent Wendy to this friend, and I hope it will help her as much as it helped me. So one of the keys is a do-it-yourself. This is a do-it-yourself inspiration or a do-it-yourself motto. So if a 3D printer can inspire you in your daily work, and it can help you to bioprint, to create human tissue and human organs with a homemade printer that also carries a name, is something that you really need to share with the community, because it's not, 3D printing is not something only for scientists or for a few privileged ones. Of course, you need something, you need some expertise. And now, Maria, maybe you can talk about your project and how you got there. But I want to insist on the fact that it is affordable. So, Maria, how did you started to work in the 3D printing field and the malaria diagnosis? Well, my project has been working for 5 years now. It's a pity because Miguel Buenga has not been able to come here. He was the founder of the project, and I'm going to talk about him a little bit. He used to work, or he works for the United Nations, for Big Data Department at the UN. So he's in charge of local health problems like malaria, HIV, and tuberculosis. And he is an engineer in telecommunications and has a PhD in medical bioengineering. And he's really very knowledgeable in these technologies, 3D printing, big data, artificial intelligence, and video games. And one of his skills, and he's brilliant in it, is how to combine several disciplines together in order to find solutions that were impossible earlier. So for the malaria problem, there are 200 million new cases every year. 200 million cases. I know you cannot imagine it, but it is 4 times the population of Spain that get infected with malaria every year. So we have to eradicate it. And for each of those cases, we spend 5,000 hours per year playing video games. So he thought, why not combining both things? Why not devising a video game in which, as we play, we can kill malaria parasites? So he started with blood sample. That was a very brilliant but weird idea at the beginning. But he convinced 2 people to develop a video game. This is the video game. Well, this is the second release of the video game, and a doctor, a friend of his in South Africa, sent him blood samples containing malaria parasites, and they devised a video game in which people could play and actually kill the malaria parasites. So it was quite attention-getting. At the beginning, it attracted the attention of the media. 100,000 people from 5 different countries started playing the video game only the first month. And Miguel analyzed how to compile all the data coming from the players who killed the parasites in the blood samples, and then tried to get the same reliability a microscope user can get. Because, of course, these players were normal players, like if you play a video game to kill malaria parasites. So the result was that by joining in a very specific way, if you put 20 people to play on the video game on the malaria parasite, you get the same reliability and the same accuracy that you get with a microscope user. So this is great for those places where not everybody can devote 20 minutes to analyze a blood sample in order to search for malaria. So you can use 20 people to play the video game, and you get the same accuracy and the same reliability. So this started in 2012, and then they did a study, and they published it in a very impactful journal of medical engineering. So they devised a prototype that was real research, because the information we had got so far was not enough for real diagnosis. But on the 11th of June 2015, we managed to complete the whole cycle, meaning having 2 people in Mozambique with something similar to that microscope, taking pictures with a smartphone and sending those pictures to the cloud. And then the distributors, the servers distribute the pictures to the video game players. And we have a PC called Frankie, a server that joined all the results, and then in less than 15 minutes rendered this image. This is the first malaria image. You can see the green squares, places where people clicked, but where there were parasites, only in the green places, only the green squares. And the rest of the cells in the rest of the sample, there was no malaria. So I was not in Mozambique, I was in my lab, but we had a live camera, so it was very exciting. So we have become specialized in getting this type of devices in order to get medical imaging in places where there are no doctors. So these pictures can be sent to where the doctor is located. So for those places where there are not enough doctors or where there is no structured medical system, you can have these devices join or get the doctor and the patient in touch. So now, this is when 3D printing comes to stage.
So the idea of iGel is a way of reinventing the current medical devices. with the new technologies. 50 years ago, there were different tools for health, and everything was much more complicated to get. Now we have new technologies such as AI, big data, smartphones, which are incredible devices we could not think of 50 years ago. And with all this, we can reinvent e-health through these devices, and we can have things much cheaper, and we can put them into the market much faster. 3D printing allows you to speed up all the device creation processes. And the speed now is amazing. When you go to bed after designing, someone on the other side of the world will wake up designing something new based on what you just did. And if something went wrong one day, the next day you will be testing a different version. So the development processes are really speedy, and they go hand in hand with patients, which is the final goal, is the final user. So Nieves, printing, how do you print properly? Well, for those of you who do not know much about 3D printing, I'll try to put it simply, the way I would put it to my mom. And it usually works out. And this is the same thing when I joined this world, because I'm an engineer. When I started with biologists, they had to explain things to me as if I were a little girl. Like, this is a cell, and you need to feed the cell, and things like that. Well, 3D printers, at the end of the day, they're machines with a platform that allows us to build objects. They work like paper printers, laying layer after layer, piling up things to create objects. Well, we do the same thing with objects. What you see, the reel over there is plastic, and I can use plastic to create things. And if instead of plastic I had chocolate, I could create cakes. So 3D printers, at the end of the day, are devices that allows us to build things with the materials we feed them. So in this case, we feed them cells. This is my final graduate project. I wanted to take cells, human cells, and put them in a specific place that is compatible with the body and that can integrate the human body. So how does skin printing work? First of all, we take a patient's biopsy. This is usually for people who have been seriously burned, or people who have been laying for too long on a stretcher. So we take a very small piece of skin, and we get both types of skin cells. We grow them in the lab, and we create the amount of skin the person needs. So with this machine, if it was a cake, we could have a vanilla layer and a cake and a biscuit layer and a chocolate layer. Well, we do the same thing with the different cells. We do this on the burn skin, the patient's burn skin, and the patient can regenerate this. This is not the reinvention of the wheel. The biotechnology is way ahead of us. In biology, you know that A plus B equals C, but we do not know why. So what we do is we reproduce what happens inside the body. So if we need to come up with C, we provide the body with A and B, and the body does it on itself. And it works exactly the same way as when we get burned. You get burned, and then you get a wound, and then you get a coagulum, and then the skin regenerates itself. So we use these natural biological methods. Now, right now we're using bone and sinew, but we could use these machines to build kind of a scaffolding for cells to cling to in order to build the tissue they need to repair. Okay, so Nieves, you explain all this And all this is being implemented in the 12 de Octubre hospital in Madrid. So if any of us gets injured, we could go to your hospital and harness this technology, or is it just at a experimentary stage? This is a very new technology, and new medical technologies require a long validation process. So these are medical devices, and for over 10 years, the skin fabrication process is done by hand, as they do in Asturias, in northern Spain. They take samples from the patient's skin, and then they create a gel they smear on the patient. So the skin is the largest organ in our body, and it prevents us from getting infection. So it's very important for us to recover it very quickly. We have been doing this for over 15 years by hand. And my project came up 5 years ago. So far, we have done all the preclinical phases. And the next part will be using it with human. So far, it's being validated. It's under clinical validation. Let me underline one thing, because I need to specify this. So far, if you want to put things into humans, you need to work with animals first. This is the way things have been done so far in order to be safe and secure. If we skipped this part, we would use humans as guinea pigs. So 3D printing for human tissue printing allows us to regenerate damaged tissue and have shorter waiting lists for transplants, but we can have samples that act such as, or a skin that acts such as human skin. And we could use this to test drugs or cosmetics. There are many companies in the US, such as Organovo. They're already working with L'Oreal, and there are also other European companies that would be very interested in this. So in 5 years, we might already have human tissues, such as skin tissue, available in hospitals. But so far, animal testing takes almost as long as human testing. So this way we could have the same final results, and maybe in 5-7 years, we could have it implemented for simple tissues. I was watching a video of an organ transplant. It was a full organ. How do you call this organ? Yeah, kidney. That's it. It was a kidney transplant, and it was about 15 years ago. That's when they had their first full transplant with 3D printers. So tell us how it works. It was a 12-year-old kid who had a fully 3D printed organ implanted. And now this kid, well, this man, 12 years later, is perfectly all right. So what are the pros and cons of this process? So right now in Europe, if we wanted to take this to the clinic, we would have to undergo a very slow process to make sure that this is feasible. In other parts of the world, they allow themselves to take more risks on human. Like people can agree to test things and speed up the process. The problem with these kidneys or those organs developed many years ago is that they were not tested. They were not enough tested. So it was a very early stage of the whole thing. And as a first milestone to get this moving, this was great. This was a great first milestone. But it was a little bit too rushy. It happened a little bit too early. So right now we are still figuring out how tissue can adapt into a body. So let alone a full organ. It's a complete structure that has a function within the human body. So what we have seen on the news is probably just the highlights. There is much more to it. So Maria, What does it mean to be a scientist in Spain? Or scientist woman in Spain? Is it easy? It's a different world. Actually, in our team, we look for girls because so far it's 6 boys and myself. So if anyone is interested, if any woman is interested, you're welcome. So the thing is that it's hard for us in Spain, and there are not many fundings. We all want our projects to be funded. We all believe in our projects. We all think it's interesting for society and for science. But actually, the money you get, if you do get it, it's very short-lived. We got 20,000 euros, which is enough to keep up a lab for a month, to pay wages and all the technology. It's enough for 1 or 2 months, tops. So we need longer-term fundings. Probably not as long as Nieves fundings, because we do not work directly with patients, but we do need the funds. We already have the microscope you saw before. We have a retinograph. It's quite a simple one. It's just a mobile phone where we have attached an ophthalmic lens, and we have put 3D printing pieces. And by widening the patient's pupil, you can get to see the patient's retina and make a diagnose. The diabetes retina problems is quite usual for people who suffer from diabetes, and they can even go blind through this. So they need to get a picture of the retina to double check that they are not having the symptoms of that disease. Okay, so very soon we will have a new app, a new game to detect the retina problems. I hope so, yeah. So the world in 5 years can be very different, but what we want is to promote the Internet of Things for medical devices. We want medical devices to be interlinked. We want to have an Apple store or a marketplace not for games or beauty or other types of apps like we have right now. We want to have medical apps. We are starting to see some of them, and it is a way of reinventing medicine. Medicine has evolved very slowly so far because of the patient's safety, of course. We can keep it just as safe, but much faster through the new technologies. And this is precisely what we want to do. We want to promote the interlinked, interconnected, low-cost devices that allow us to make faster diagnosis and that allow us to come up with better results for the patients. What do you think about education in the world of science? And what about the men and women divide? Does education play a major role for you? We both studied in the Telco School of the Polytechnic University of Madrid, and now we are creating a startup to market all the projects, all the products we have come up with, and we want to take them to the market because it's useless to keep them in the lab. And from the university, they promote our projects and the dissemination of our projects, and they asked us to give talks or shows for kids. And it's actually very catchy for them. Do you have any picture of of kids playing. Children loved it. They loved their video game. They get this feeling that they can contribute to important problems such as malaria. Can we see the next one? Here you can see some of the events we have launched with Eurospot. This is the malaria sport video game, and kids are thrilled. They love it. They love knowing that they can help solving big problems. There are always funny stories. Like every year we have the International Malaria Village in April. And we have our Olympic Games against malaria, and we invite over different schools to take part in different ways. And this year, for instance, what we did was we got some malaria pictures with an algorithm, and we wanted to use those very same images and have them diagnosed by the children taking part in the Olympic Games. And we wanted to check whether children or machines do it better, or both together. We wanted to know how they can work together, how humans and machines can work together to come up with even better solutions than separately. And how are the results? Well, many kids joined in. We had about 20,000 kids from all the country, and we still don't have the full results, but we believe that the results are good and the combination is perfect. As a funny story, let me tell you that kids have to write notes with their impression, and they're great. They're great. They're not embarrassed at all when they have to say when they have to speak their mind. One of them said, "This is more addictive than Coke," and another one went home and wrote, "I loved your game. I draw video games, and I also play. I play the saxophone, and I do this and this. What do you want me to do for you?" So this is great for us. We love it, and this really encourages us. And kids have a great power, and it's very interesting for them and us. What do you think? What do we need to change in Spain to have more bioprinting research? How do you think we can improve your field of expertise? To relate this to what you said before about education, I believe that it all has to start off from the very beginning, from the earliest years. Very often children think, okay, I get all this theory, but what is this for? They usually always ask this. They always ask, what is this for? What's the use of it? So from the beginning, when they are very young, we have to explain the theory, but we also have to show them what they can use with it, what they can do with it. So by having them using small robots, we introduce them to this new world. So when it comes to spending long hours working on this, they're very willing to it, and they even want more. So we want to have a scientific researcher profile in our society in some years. Not everyone needs to be a researcher or an engineer or things like that, but we do need to help those who want to become a researcher or engineer. We need to promote this and encourage children, because things are not looking very bright so far, but the future can be brighter if we prepare our kids for it. In the world of research, collaborations sounds great. But it's great to be on papers and publications. And this is the way the system works. People want to collaborate just to be named in an article. But we need to make a shift and evolve from here and really collaborate, not just to be there, to be shown in an article, but to work together and build up together. This is related to the city scientists you mentioned before and the shared economy. And we welcome everyone's opinion. Maybe one thing we could do would be to encourage citizens, not just through talks, like what we do in schools where we show them all they could do, but also to allow them to access this world later on. Because sometimes in the talks you give them information and that's the end of it. We want to promote a continuous exchange. And this is not just about 3D printing. This is also about the Fab Labs and other kinds of labs where they can participate. There is a picture of a web we are working on right now. It's called Open Bioprinting. And the origin of it is the problems we all have to face. All of us are facing problems with technology. And many people are working in the same field and they are not sharing their expertise and their knowledge. So now what I do is I go to congresses, and when someone is presenting their whatever, and I identify some problems I already faced and I've already sorted out, I always go to talk to them so they don't have to face the same thing. And they don't trust me. They don't trust me. We are not used to having people giving us free information. People, they don't trust us. So we launched this platform to give researchers a tool to share problems. And this is not only about researchers, this is also about anything, such as Fab Labs, web labs, biology or chemistry web labs. And sometimes someone's problems are someone else's problems too. And we can help each other. And this is precisely what we are trying to do with this hub. Some people are creating low-cost lab equipment that could be reproduced anywhere. And this is a project we are dealing with right now. And very soon we will put all the information online. And the final goal is to have anyone understanding this. This is not only for engineers. We are working to disseminate this to the general population to change things and make it, bring about that necessary change. That's wonderful, wonderful. Well, apparently it's time now to give the floor to the audience. My final question is, I started with what you did your last day of work, and now my final question is, what are you going to do on your next day of work? I'm going to write the proposal. That's it. Yeah. We need to come up with a good proposal. Well, I'm going to do more management work. I'm more into management, so I'm not that aware of the technological advances. We are looking for funders, public and private funders. Technology is moving really fast, so you can have an impact if you are fast at developing and you can reach the market fast. And for that, you need fuel. you need a lot of fuel, which is a lot of money in very little time. So we have already put all it takes. We have done all it takes. We are talking to investors, to business angels, to people who are not only after returns to their investments, but they are also after a social impact. These investors obviously want to make money, but also they want to make money with something that's good for society. And you see them smile when you tell them your story, so I think we can have a happy ending with this story. Yes, with the Hassani brothers and what we are listening to right now, we have a great pool. So if there are any prospective investors or funders in the room, please feel free to contact them. Now I give the floor to all the audience in case you want to ask any questions to these amazing Spanish researchers. So what questions do you have on bioprinting, human mutations, where all this heading? Do you have any questions from the audience? We have 7 minutes. Please do not rush at the same time. One by one, please. Oh, I have a question about the video game. What's the margin of error for the artificial algorithm? Could we use it as a CAPTCHA? Could we use a CAPTCHA for this? Or a verification number? I don't know whether I understood your question. Why don't we use a CAPTCHA to know whether these people are not robots? Okay, I think I get it now. We thought about it, and that's actually a great idea. We thought about image analysis rather than numbers to have images as they do on CAPTCHA. We believe this is a great suggestion to show images of malaria or things like that and ask people whether there are black spots or whether the figures are rounded or square. We could use it. We could use some of that. Having short images and ask people to do micro tasks is great because the human eye is much more powerful than any machine. We can understand images much better than machines do. So this is feasible, yeah. Can you play on Facebook? Well, you can link it on Facebook. No, but we're not on the platform itself. Have you talked to them? Well, Facebook actually created the AI algorithm to identify these images, and in the latest Olympic Games against malaria, we used their images for the children. So we are related to them in some way. Any more questions? Regarding the talks and presentations in schools, do you do it throughout the country or just in Madrid or the Madrid region? Well, so far I have gone to the schools that have contacted me, and actually all of them were from Madrid, but we are open to other things. As long as they cover our travel expenses, we are willing to go anywhere. Same thing for us. We love disseminating our ideas. We love getting feedback from children. And it's great for us because we get lots of ideas from them. And it's also a different way of testing our technology. We work in Madrid, but we are ready to send the material anywhere in the world. For the Olympics, we have several schools from northern Spain. Actually, the people from northern Spain won the latest edition, so it's feasible. Is this working? Yeah. Okay, about the project we're working on, there is a very important part on fusion. One part of our budget is allocated for the dissemination and exploitation of our project and to cover travel expenses. So if this works out, we could disseminate it much better and help create ideas or projects such as this one somewhere else to replicate it in other hubs. Any more questions? Okay, so we can wrap up. And Nieves, Maria, thank you very much for coming to Malaga and tell us your story. Good luck for the future and all the best. Thank you. Well, as you know, we're going to go upstairs for a coffee break, and we can take advantage and chitty-chat for a little bit. So see you in 30 minutes. 30 minutes, sorry.